Okay, on this video we are going to do a summary of the three cases and what happens and what to do in those cases, and here just an example of each one of the cases. Okay, the first one that we saw was real different roots. So in generic form, this is the constant coefficient second order differential equation equal to 0, and this is the characteristic equation, generic characteristic equation, and here is the chicharronera. Okay, now to have real and different roots, this should happen. B squared minus 4ac must be bigger than 0. This number is from the number within the square root. Now, if this is bigger than 0, then we have real these different roots. So what will happen is m1 is going to be different than m2. So my first solution is going to be exponential of m1x, and my second solution is going to be the exponential of m2x. Okay, so the homogeneous solution is going to be c1 exponential of m1x plus c2 exponential of m2x. All right. Okay, so this is the formula for this case. Now, just to remember why we have real roots is, imagine that the characteristic equation is actually the equation of a parabola. So this is the parabola. When the parabola is in this shape, then you have here your m1 and this is your m2, and they happen to be different, right? And real and different roots. Okay, so this is the easiest. Now, when we have repeated real roots, so that will take place when, again, this number b squared minus 4ac is exactly equal to 0. When it is exactly equal to 0, so it's going to be minus b plus 0 and minus 0, so it's going to be still real roots but repeated. Okay, so what happens here is that your m1 is equal to your m2. So your first solution is going to be, as we saw in the previous video, exponential of minus b over 2ax, and your second solution with the order reduction formula is going to be x exponential minus b over 2ax. Okay, and that's it. Now, using the same analogy with the parabola, what happens here is that your characteristic equation is going to be something like this. So you push a little bit the parabola, and these two roots have joined together in the same point. So m1 is equal to m2, and that's what happens. By the way, the homogeneous solution is c1 exponential minus b over 2ax plus c2x exponential minus b over 2ax. You can factorize the exponential, but it's still the same solution. Okay, case number 3. Case number 3 is when we have this case when b squared minus 4ac is less than 0, is negative. So as you can see here, the cases are related to this number, b squared minus 4ac, bigger than 0, equal to 0, or lower than 0. So we saw that the first solution in the previous video is going to be, and we have the roots are, m1 and 2 is equal to alpha plus minus beta I. So your first solution is going to be exponential of alpha x cosine of beta x, and your second solution is exponential of alpha x sine of beta x. So your homogeneous solution is going to be exponential of alpha x c1 cosine of beta x plus c2 sine of beta x. Okay, now using the parabola, what happens on this characteristic equation is that the parabola is up, so it's not possible to be equal to 0. So the roots are in another dimension, in the imaginary dimension, not in this real dimension. Alright, so you don't have real roots, just in imaginary. Okay, so these are the formulas, engineers. The formulas that you are going to use, this one, this one, and this one. I may add another case here. Another case is when it is pure imaginary, when the alpha is equal to 0. Okay, but I don't have a space. I'm just going to talk about it. When alpha is equal to 0, what happens is that the exponential of 0 happens to be just 1. And the solutions are just the cosine and the sine. So the homogeneous solution will be this cosine and this sine. But in order that to happen, the b must be equal to 0. Okay, if b is equal to 0, so this vanishes, and this is 0, so obviously it is imaginary root. So that means that for that case, this should happen, an squared plus c, meaning that this part doesn't exist. The b is equal to 0. I don't have a space, but that case is inscribed here, right? Just a special case when alpha is equal to 0. Okay, now let's do the examples here. For this example, the characteristic equation is this: m squared plus 3m plus 2 equal to 0. The roots are m plus 1, m plus 2 equal to 0. So my first root is minus 1 and my second root is minus 2, right? I can write each of the solutions, but I'm going to jump directly to the homogeneous solution. C1 exponential minus x plus C2 exponential of minus 2x, and that's it. Piece of cake. Okay, now the order doesn't matter. I found first minus 1, but you in your homework or in your problems you could have found first the minus 2. It's just the same solution. It's just that this minus 2 is going to be here and the minus 1 is going to be here, but it's the same, exactly the same solution. Okay, now the other repeated root case is going to be m squared minus 10m plus 25 equals 0, m minus 5, m minus 5, they are clear, the roots, right? So m1 is equal to m2 and is equal to 5. So my first solution is exponential of 5x, and the second solution is just x. I'm going to write it, the first solution exponential of 5x, and my second solution is just x times the first solution, 5x. The homogeneous solution is going to be c1 exponential of 5x plus c2x exponential of 5x, and that's it. Now on the imaginary roots, I think we have seen this, and the roots are, if I remember correctly, the roots were like this: m and 2 is equal to, what was the roots? 2 minus 2 plus minus the square root of 3i. I think that was the roots of that. Just let me check. Yes. Okay. So what you should do is just replace here the value of alpha and the value of beta. Okay? Now on the value of alpha you have to respect the minus, and on the beta you have positive and negative. But remember this, the positive goes with the cosine and the negative goes with the sine. So you don't lose the sign, it's just that they are here in the cosine and the sine. So I'm going to write the solutions. The first solution is exponential minus 2x cosine of the square root of 3x. The second solution is exponential minus 2x, the sine of the square root of 3x. And then the homogeneous solution is going to be exponential minus 2x. I factorize the exponential, c1 cosine of the square root of 3x plus c2 sine of the square root of 3x. And there you go, you have your solutions for the three cases. Alright, I'm just going to split this. So engineers, what you have here is the methodology to find the solutions for constant coefficients and equal to 0. Homogeneous as long as they are constant coefficients. Now, you cannot apply these rules when the coefficients are variables, so that is going to be another video. Alright, so see you on the next one.